Hello everyone. Welcome to a brief introduction to the Snort conversion utility that we have developed here at IDT. So the Snort conversion utility is basically used to overcome some of the limitations we have, like that of the unsupported Snort constructs in our NSP, and to provide a proper conversion of Snort signatures to the native NSP format. The design for this particular utility is pretty simple. This is the basic design flow. The customer imports snort.rules and snort.conf file to the snort conversion utility. The conversion utility then performs analysis on every snort rule and determines if it can be converted to the McAfee native format. If such a conversion is possible, then the utility converts the snort rule to the McAfee native UDS format, which can then be imported using the NSM's UDS import wizard. For those signatures where such a conversion is not possible, mostly due to unsupported snort construct, the utility will then try to optimize the snort rule such that it can be imported to the NSM without any issues. These optimized snort rules are then imported to NSM using the UDS import wizard. But these rules would not be in the McAfee native format, but rather in the snort format. So the basic purpose for this was to address the various PCRE limitations. Most of the snort rules support complex PCRE expressions. Some of these expressions are not supported by NSP due to the increased performance issues. So to address such cases, the utility will try to optimize the PCRE expression by building a superset of expression on the fly, which will carry the same meaning but would be optimized for NSP. The PCRE expressions may be broken down into multiple expressions so that the support is possible and they are detected properly by the NSP. Since the utility is building a superset of expressions, there's a chance for false positives. But we at IDT, we are determined to reduce these false positives and to improve the detection rate in the future versions of this utility. For the current version 1.1 that we have developed, these are the various highlights of this utility. Version 1.0 is a command line utility, a POC in the crude form, which is basically used to demonstrate how this utility would work. As of now, version 1.0 has the ability to convert most of the snort rules directly into the McAfee native format. The utility can detect proper protocol corresponding to a particular snort rule, and it can map the proper S fields for better detection. The utility has a PCRE pre-filtering engine, which does the basic job of filtering out unsupported tokens to get the superset expression, which can then be used by NSP. These optimized PCRE expressions will be further improved in version 2.0 for better results. In the future release of version 2.x, here are the proposed features. Version 2.x will be much stable release with optimized PCRE and snort constructs. These optimized snort rules should be imported to the NSP without any issues. Version 2.x will have a web interface so that customers can log in directly and pass their snort rule. Those unsupported, not converted, or converted with error rules will be reviewed by IDT. Version 2.x will also have support for flowbits and track by snort constructs. Further, it will have improved logging and debugging messages. This will basically help the customer understand what went wrong with the snort rule and why it was not converted correctly. In version 2.x, we are also planning to support certain constructs which are not supported in this version. Next, we have a demo of how this utility works. So here is the demo. There's basically a snort.util folder. This is the snort.util folder. This is the main bash file which would be used to execute this utility. Now, for executing this utility, basically what we need is an input file, which in this case would be, this is a snort.rule file which will go as an input to the utility. Let me open this. Okay, this is the snort.rules file, and for the demo purpose, we currently have a around 26 Snort signatures. Yeah, we have 26 signatures, and this includes a random collection of various Snort rules collected from various websites like Emerging Thread, and it includes various complex PCRE expressions also. As you can see here, uh, this is one PCRE expression, and even we have support for such complex PCR expression, as you can see in this case, and huge Snort signatures. So what we'll do is, this is the snort.rule file which will go as an input. We also have an output folder here which is currently empty. This is where the output converted rules would come in. Now we open our CMD. We go to the snort conversion utility 1.0 folder, and here we simply execute the snort import.bash file. We give the snort.rules file as the input argument, and the output folder as the output argument. Now I'm executing this particular utility. Yeah, here it goes. And now when I open my output folder, see, this is what I can see. This folder basically contains those signatures which got converted to the native McAfee format, attacks.xml and packet grab protocol.xml, which can then be converted into a UDS and imported on our NSM. I'll just open this and show you. Yeah, this is the attacks.xml, which has the various attacks which got converted. And this is the Snort optimized. Now these are those which could not be converted into the McAfee format, so they were optimized into a better Snort rule which can then be imported into NSM directly. So web.rules is basically HTTP based rules, SMTP, FTP. So they are classified on the basis of protocols. I'll show you these rules also. Yeah, so see, these out of those, these were the rules which got converted to Snort format, optimized Snort format. Add these two in a zip form and then create a UDS out of it. Yeah, I'll open my NSM. In NSM, under policy, IPS policy, we go to custom attacks. There I'll be importing these. Browse. I'll browse to the location where this UDS got created, attacks.zip, which I just created. I'll import it. I'll uncheck all boxes and I'll just check the import native McAfee attack text box checkbox, and I'll import the signature. See, the import is currently going on, and now it's complete, and it shows that it successfully imported 13 of those signatures. So, and I can now save them, and they will get saved, and then I can push them onto the sensor so that they can be pushed and used as any other signatures.